Here we have electrostatics question number 4. A rod with a charge of 50 nanocoulombs is brought close to a 4-gram piece of paper. Paper starts to float when the rod is 5 millimeters away from the rod. What is the charge on the paper? All right, so we have our diagram here. Now the paper won't accelerate until the electric force overcomes the gravitational force. So there's two forces acting on it. We've got the gravitational force, which we can get as mg, and we've got the electric force, which we know is k q1 q2 over d squared. So when they equal each other, that's the point at which it would start to levitate. All right, so let's go to our givens. We know the charge on the rod will come at q1 is 50 nanocoulombs. So nano is times 10 to the negative 9. It gets close to a piece of paper. So the piece of paper has a mass of 4 grams, but we always use kilograms when using an equation. So we need to convert it. So we need to move it 3 times to the left. That's 0.004 kilograms. And the paper starts to float when it is 5 millimeters away. So again, we need this in the proper units. Millimeters is too small. We want meters, so we need to move it 3 times to the left. So the distance is going to be 0.005 meters. So it wants to know the charge on the paper, so it's going to be our Q2. So we've got our electric equation, K Q1 Q2 over d squared. We also have our gravitational force equation, Fg equals mg. So we should start off by calculating the gravitational force first. That's pretty easy. Fg is equal to the mass, 0.005, times the acceleration due to gravity, 9.8. So that gives us a gravitational force and an electric force, because they're going to set them equal to each other, of 0.0392 newtons. All right. Once we get the force, now we can solve for Q2. Since we're dividing by d squared, we need to multiply both sides by d squared. So we're going to get d squared f is equal to k q1 q2. And then to isolate q2, we need to divide both sides by k q1. So those are going to cancel. So our equation should be d squared f over k q1. So now our values are either here in our givens, or we just solve for them. So we can say Q2 is equal to d squared, so 0.00, I messed this up. The mass is 0.4. The distance is 0.5. That's squared times 0.0392 divided by 9 times 10 to the 9th and 50 times 10 to the negative 9th. Make sure to put your whole denominator and probably your numerator in parentheses so it does the correct order of operations. If we grind this out, we get a charge of 2.18 times 10 to the negative 9th coulombs. But this has to be an attractive force, and since the rod is positive, we have to make the paper negative for it to be attracted. We can also write this in terms of nanocoulombs, so we can get rid of the scientific notation, because we know nano is times 10 to the 9th. So we could say that it is equal to negative 2.18 nanocoulombs. So we got our 3 sig figs, proper units, and we've blocked our answer.